So yesterday when I wasn't here, we took a look at vector addition. We started off with vector addition where we had 2, 3, 4, 5 vectors, all at 90-degree angles to each other. Those questions weren't crazy hard because the angles, again, were all either 0, 180, or 90 degrees. They're doable. Okay? We have to know how to do them, but they're doable. The next set of questions we had, which would correspond to 4, 5, and 6 in the worksheet, were a little bit more challenging because we had funny angles. Angles of 30 degrees, angles of 50 degrees, 28 degrees, so on and so on and so on. Let's do one question from your worksheet of the 90 degree type. The ones where it's everything's at 90 degrees. And then we'll do another example of when we've got funny angles, and what we do with those funny angles, how we get rid of those funny angles. So without further ado, let's do question number 3 on your worksheet. It looked like this. You had one vector to the left that was 20 meters. We had 10 meters downwards. We had 10 meters across. Notice that I'm drawing this more or less to scale. The 10 meters is about half as long as the 20. The 5 is about half as long as the 10. It's not perfect. That's okay. Hey, I could do a better job if I used a ruler, but it's not the end of the world if it's not perfect. Just do it more or less to scale. Now, that vector diagram is drawn correctly, right? You didn't have to draw that because that was already drawn for you on the worksheet. But it's drawn correctly because all the vectors are drawn front to back. The resultant vector, though, the resultant vector should be drawn opposite to the rest of them. It should be drawn from start to finish. So it should be drawn right here. It's front to front and back to back. Now we got to find the value of that resultant vector. But because we have 4 vectors here, 4 blue vectors at least, we don't have a triangle. We've got a 5-sided shape. What do you call that? I don't even know what you call that 5-sided shape. Pentahedron or something? I don't know. Doesn't matter. We got to turn it into a triangle, a right angle triangle. And the way we're going to do that is to break it into x and y components. Now remember that x is this, and remember that y is this. So let's go through each of those vectors. And let's determine how much is x and how much is y. First vector. Okay, good. Yeah. First question, or the first vector I should say. How much of that 20 meters is x? Good. Negative 20 because 20, obviously, because it's all on the x-axis. Negative because it's going to the left on the x-axis. So negative 20 meters. How much of that one, by the way, is y? 0. None. Right. Second one. How much of that 10 meters is on the x-axis? Look at the picture. How much of that 10 meters down is on the x-axis? Got it? Good. 0. How much of it is on the y-axis, Atlanta? 10, but we're going to make it negative because it's down. Okay. Third one, how much of that 10 meters, how much of this 10 meters is on the x-axis here? Good. Good. Positive 10 this time, right, because it's to the right. How much of that 10 meters is up or down on the y-axis? Zach? 0. Good. And finally, the 5 meters, how much is on the x-axis? Derek? Good. And on the y-axis, how much of it's on the y-axis? Good. Positive 5 because it's up. It would be negative if it was down. So we add these up. 20 plus, negative 20 plus 10 gives me negative 10. This gives me negative 5. Now we're going to redraw it because remember the goal. We said the goal, very first time we did this, we said the goal is to always have a right angle vector diagram. Right angle triangle vector diagram. We didn't have that, but now we can get it. So let's redraw what we just found. We got 10 meters to the left. We have 5 meters down. And my resultant vector goes from start to finish. Have a look at the resultant vector that I just drew, and let's compare it to the resultant vector up here that I had in my original diagram. What do you notice about those two? Don't they look pretty much the same? They should. If we draw it perfectly to scale, they should be exactly the same. Now, we want to find the value of this resultant vector here, and we also want to find the angle. The angle that is, by the way, always drawn at the start. R is going to be found by the Pythagorean theorem. A squared plus B squared equals C squared, or C is equal to the square root of A squared plus B squared. What's that going to be? The square root of 125? 12.1. 12. Theta is equal to the inverse tan. Oh, goodness. Yesterday, you guys saw the trigonometry, right? The angle stuff. Remember sine, cosine, tan? When I was in high school, my math teacher, Mr. Heffernan, taught me 2 ways to remember sine, cosine, tan. Okay. Sine, cosine, tan was Oscar had a heap of apples. Oscar had a heap of apples. Right? Sine, opposite hypotenuse. Cosine, adjacent hypotenuse. Tan, opposite. What's that? Yeah. I put an A. Should be an A. See? Because I remembered Oscar had these apples, I remembered that I was wrong there. Okay. It's as if I made that mistake on purpose, right? Which I did. So sine is opposite of hypotenuse, cosine is adjacent of hypotenuse, tan is opposite of adjacent. Now the other way that I learned it, this is I think the way that you guys usually learn it is so technical. Spelling is so total. I don't care how you remember it. Just remember which sides go with this trig function. Now, if you look at this triangle, I'm trying to find this angle right here. I have the opposite side. I have the adjacent side. Which trig function am I going to use? Tan, because I've got opposite and adjacent. Now, technically, I've also got the hypotenuse here as well, right? 12 meters. I don't want to use that. Why not? I could actually technically use that. But why do I not want to use it? Yeah. What if I made a mistake? What if it's not really 12? What if it's 38? And I just made a mistake. Okay, if I use the 10 and the 5, I'm less likely to get my angle wrong because there's less likely to be a mistake with the 10 and the 5 than for the 2. So I'm going to go back as far as I can and use opposite adjacent. Now, if you're solving for theta, you've got to say theta is the inverse for the second function 10 of opposite over adjacent. The opposite side is 5 here. The adjacent side is 10. Don't worry about putting in negatives for those. At this point, you can drop those negatives. Those were important for getting your diagram drawn in the first place. Okay, let's take a look at our calculator here. Let's first check to make sure our calculator is in degree mode. Click mode, and it should say degree right up there. If it doesn't, then switch it to degree, because that's where you should be all year in Physics 20. Now, let's do the whole inverse tan function. So we're in degree mode. We're going to say second function tan, okay, second function tan, and then we're going to say brackets 5 divided by 10. Make sure you end the bracket there. We end up getting an angle of 26.6 degrees, or rounded to 2 digits, it would actually be 27 degrees. Is that okay? How many people got number 3 right? Okay. You guys still good with that? It's south of west, or yeah, that's a little bit confusing, isn't it? There has to be a frame of reference, right? Remember the first day of class, we talked about vectors and scalars, and we used the analogy of Dairy Queen. I can't remember who we used in the analogy of, of somebody taking somebody out to the movie. You live 20 kilometers or whatever it was away from Dairy Queen. Like you have to have a reference point, right? Like 20 kilometers to the north of Dairy Queen. 20 kilometers at whatever direction. 27 degrees means nothing here. It really doesn't mean anything. 27 degrees from Dairy Queen. Oh, 27 degrees from Dairy Queen. What does that tell us? 27 degrees, like, of what from Dairy Queen? This is going to be what we call 27 degrees south of west. because the west axis here is our reference line here. How do we know that? Because the angle's attached to it. But then where do we go from the west? Well, we didn't go north because this is north. We went down here. The angle is south from the west, south of west. Now, there's another way to think of it as well. Okay, look at this angle here. To get to the end, we went west, then we went south. We went south after we went west, right? So that would be south of west. Yep. Sorry, say what? Yes, yes. Good. That's a good question. Brian drew like this. He said 5 down, 10 across. Well, the angle that he got is obviously going to be different because his opposite side is 10 instead of 5. His angle would have been 63 degrees. But look at where it's measured from. That 63 degrees is measured from the south. So it's not south from the west. It's west from the south. Let's look at the other way. We went south, then we went west. We went west after south, or 63 degrees west of south. Those are both the exact same answer. How can they both be right? How can you have two different, completely different numbers that are both the right answer? Well, let's look at this. Tyler is 3 meters from the back of the room. He is 6 meters from the front of the room. Do those numbers both describe his position relatively accurately? Sure they do. It's two completely different numbers. It's just where we're referencing the number from, right? 2 meters from the back of the room, 6 meters from the front of the room. They both tell us the exact same thing. So why can't those two completely different angles tell us the exact same thing? They do. So on a test or on a quiz, I don't care which one you give me. They're both absolutely correct. Now, what you'll find, Bryant, is I almost always draw the X one first and then the Y one, but that's just out of habit. Okay, so that's always going to mean it's going to be south of west instead of west of south. But there's no good reason for doing that one that way. It's just habit, the way that I do it. You do it this way, absolutely fine. Right? All right. Well, let's do an example here then of the stuff that you saw yesterday towards the end of the podcast. And then I'll leave you with questions 4, 5, and 6 if you haven't already done those. Okay. Let's have a 10-meter vector this way. Let's have a 10-meter vector this way. Let's do a 5-meter vector this way, and we'll make it at an angle of 30 degrees. You guys figured out why I like 30 degrees yet? Yeah. Easy to work with, right? Sine 30 is 0.5. Cosine 30 is 0.866. I don't remember all the other ones. So I always use 30 degrees because it's easier to do, a little bit quicker to do. All right, the resultant vector, remember, goes from start to finish right here. We gotta do really the same thing as we did in this question. We've got to turn it into a right-angled triangle that we did towards the end of this question. But my issue with this one is that I got a funny angle. And we all know how much I disdain funny angles. So we got to get rid of it. Yep. Oh, good question. That was supposed to be 5. I don't like funny angles, so I got to get rid of it. Let's go off to the side over here and redraw just that one. Let's do it in green, actually. Let's brighten your day up a little bit by having more colors. Red, blue, and green. Here's 30 degrees. This is the X side, this is the Y side, and this is 5. Okay. So you guys, a couple of people told me you're learning trigonometry in math class right now. You guys learned sine, cos, and tan though, like before grade 11, right? It's just more intense trig in grade 11, right? You guys learned sine, cos, and tan probably in grade 9, is that right? Grade 10? Okay. But you know it, or at least you've learned it. Whether you remember it or not, you've learned it. I want to find the X side. The X side is which side of the triangle? Opposite, adjacent, or hypotenuse? Yep. It's adjacent. Good. We have the hypotenuse. So let's use cosine, adjacent, and hypotenuse to find the X side. cosine 30 degrees. No inverse cos this time because we have the angle. We're not trying to find it. We have it. Cosine 30 is equal to adjacent over hypotenuse. That's going to equal 4.33 meters. The y component is the opposite side. And the opposite side, along with the hypotenuse, requires us to use the sine function. Sine 30 is equal to opposite over hypotenuse. Now, here's what I like to do. You don't really need to do this, but this is what I like to do. I don't like funny angles, so let's get rid of the funny angle entirely. So this is what I like to do here. Replace that with this. I got 4.33 to the right. I got 2.5 up. Right? That's the exact same thing as what I had, except I had that expressed with a funny angle. Now I have it expressed with two separate vectors, both at 90 degrees to each other. So, man, now we can just go back and treat it like we did this last problem. Okay, it's all 90-degree angles, x and y. The x component of the first one is 0. The y component of the first one is -10. The x component of the second one is 10. The y component is 0. The x component of the third one is 4.33. Remember, it was 5 meters at 30 degrees. Well, now we're saying the x component is 4.33. The y component is 2.5. Make sense? Add them up. 14.33. Add these up. Make 7.5. Redraw it. We've got 14.33 to the right. We've got 7.5 down. And look at what we end up with. When we get that final velocity, it looks an awful lot like that final velocity that we had in the first diagram. The angle is always drawn from the start, right? Start to start, right? Start to start, draw the angle there. And of course, V is the speed that we're looking for here. So V is the square root of 14.33 squared plus 7.5 squared. Let's do that as a group here just to make sure we can. (14.33 squared plus 7.5 squared). Square root that. That's 16.1, which we're actually going to round to 16. Sorry, I called that V. What should I have called it? R. Doesn't. You know what? It wouldn't be the end of the world if you called it V. It's just a symbol, right? I was just thinking physics 30, first period, we did something similar and called it V. As far as 16 meters, the angle we're going to find by using the inverse tan function again of opposite over adjacent 7.5 over 14.33. Your calculator still should be in degree mode if it was the last time. Let's say second function, tan. Everybody do this, okay? Everybody do this. You think you can watch me and then go ahead and do it? Yeah, well, you might be able to. You might be good at it just by watching me. But you're a lot more likely to be able to do it right if you actually do it instead of just watch me do it. So let's go second function tan of 7.5 over 14.33. End the bracket. I get 27 degrees, 28 degrees. Hey, can anybody tell me what that's reference to? 28 degrees what of what? Okay? No, but you're close. Yeah, south of east. 28 degrees south of east. Look, we went east, then we went south. We went south after east, or south of east. And look at it as well, right? The angle is measured from the east axis, or of the east axis. So it's 28 degrees south of east. Now, Bryant probably would have gotten 62 degrees east of south when he does that. Or he could have, because he might have drawn the y-axis first. Doesn't really matter. Both the same answer, right? Got it? So we're going to finish up worksheet number, or the worksheet that you were working on yesterday, questions 4 to 6. If you finish that, then you're going to do this question right here. Take a few minutes to work on those, and then we'll look at it as a class. All right, everyone, we're going to take a look at number 5 from the worksheet. And number 5 looked like this. Oh, look at that. We had an angle of 40 degrees. Wow. Change it up. Boy. Okay, so the resultant vector here is going to go from start to finish, which is very, very short resultant vector this time. And it kind of looks like it just, with the way that I have it drawn at least, kind of just makes it into a straight line. We don't know that it does because this diagram isn't drawn to perfect scale. It's close, but it's not perfect. So that red line and that blue line may not form one straight line. Doesn't matter whether it does or not. Now, the first thing that we do here when we see this picture, other than draw the resultant vector, is say 5 words to ourselves. And those 5 words are, I don't. Good. I don't like funny angles, so let's get rid of it. Sometimes people try to draw it right in the diagram. You know what? It becomes cluttered. It just becomes really cluttered. Draw it off to the side. You got all the paper in the world. Guys, those packs of 150 pages were like 5 cents at Staples at the beginning of the year. Okay? I got tons of it. If you claim you don't have enough paper to go off to the side and draw it, I'll give you paper. Hey, go off to the side. Draw the 10 meters over here. Don't try to go through that process on this diagram. Okay? It's just going to get cluttered, and you're just going to make a mistake. This is 40 degrees. This is 10 meters. This is my x, and this is my y. Okay, the x component is which side of the triangle? Opposite, adjacent, or hypotenuse? Seth, x side, opposite, adjacent, or hypotenuse? Good. So we're going to use the cosine function here because we have hypotenuse and we're looking for adjacent. Cosine 40 degrees is equal to x over 10. I don't know why I made that 40 because I can't do this one in my head. What's 10 cos 40? Anybody got that? Thank you, Aiden, for that really fast answer. 7.66 meters. We're going to say sine 40 degrees. This is the opposite side, right? Opposite over hypotenuse. Aiden, do you have that one? 6.43 meters. Hey, x component, y component. Let's take those two values and replace this vector that we see up here with this. I don't care whether you go x then y or whether you go y then x. That doesn't make any difference in the world. Like I said a few minutes ago when Bryant was asking the question, I usually go x first then y, but not always, and it doesn't really matter. 7.66 is x, y is 6.43. Let's add all these up now. I got 0 meters for this one, neg 20 for the y component, 10 meters for x, 0 for y, 0 for x, positive 10 for y. And finally, my fourth vector that I actually replaced with 2 vectors becomes what for x? That green 10-meter long vector that I had, the x component of that is 7? I'm sorry? Good, but we're going to make it negative because it's to the left, right? Negative 7.66. And the y component is positive 6.43. Okay, so let's add these up. This one gives me 2.34 meters, and this one's going to give me 16.43 minus 20, 3.57, negative 3.57. Okay, let's redraw it. I got 2.34 over. I got 3.57 down. My resultant vector is drawn from start to finish. And if we take a look at our original diagram, boy, this is a lot smaller of a diagram, but the resultant vector still looks a lot the same, doesn't it? Okay, let's find out what the value of that resultant vector is. R. Simply 2.34 squared plus 3.57 squared. Aiden, do you have that? Thank you. We're going to actually round that just to 4.3, because if we look back to our original data, we always take the least precise one, and they're all 2 digits, right? So let's go 2 digits here. 4.3 meters. Although I've told you guys until after the first test, I'm not going to mark out any of that stuff wrong. Theta, where do I draw? Hey, where do I draw theta here? I'm going to give you 3 options. Position 1, position 2, position 3. 1, 2, 3. Where do I draw theta? Yep, 2. Good. Draw it at the start, right? There's my start, tail to tail. Always draw your angle at the start of the diagram. It's the inverse tan of opposite over adjacent. The opposite is 3.57, and the adjacent is 2.34. Calculate that angle. And Aiden, do you have that one? 57 degrees to 2 digits. Good. And something of something. Look, we got a south and we have an east. Is it south of east, Jordan, or is it east of south? Good. We went east, then we went south. We went south after east. Or you can look at it the other way. The angle is drawn not from the south vector. It's drawn from the east vector. So it's south of east, not up south. How many people got that one? Good. You guys are doing well. All right, you have about 5 minutes left in class. Keep working on these. Okay, if you haven't finished off question 6, please finish it off. If you haven't finished off that one that I put up on the board, please finish it off. If you have finished up that one you put up on the board, then get a bit of a break for 5 minutes. Okay.